So you've got about a minute to go and collect any resources that you need, and then you can have a think about what we were doing about last lesson. So how do mountains become sand? And it's based on those processes of weathering and erosion that we discussed last lesson. Choose your answers from the 6 that are available. I'll give you a clue. There's 3 correct ones. Okay, so hopefully you got those 3 correct answers based on our work from last lesson. Now, we're going to move on, and in today's lesson, our challenge is for you to be able to describe the appearance of sedimentary rocks, and our aspire is to be able to explain how those sedimentary rocks are formed. And there'll be a number of key words as we move through the activity for you to be able to use. This is one way that you could record the information. You're going to need to know the meanings and be able to describe the keywords of transport, deposition, compaction and cementation. And you also need to be able to describe the characteristics of sedimentary rocks. If you prefer, you can do this as a table or just notes. This is just an idea that some of you may wish to use. So we need to move on and work out what happens to the rocks after weathering. We know that weathering breaks down large rocks into much smaller particles and eventually into fine particles like sand. But mountains aren't covered in lots of sand at the very top of them. So our question is, where do all those tiny fragments of rock go and what happens to them? Well, in some cases, large chunks of rock fall off mountains. This is known as a rockfall, and you can see an example of a picture there to the left-hand side. And it's really due to gravity working on rocks that have already been loosened and broken off from the main part of the rock through methods like freeze-thaw weathering. And some areas are very prone to this along mountain sides, and you might actually have driven past signs like this that show that this is an area very prone to rockfalls. And as you can see up in the top corner there, it might be that they have actually had to put wires to try and catch those falling rocks if it's going past a road. Another way that rocks are moved is when they find their ways into places like rivers and streams and are swept away by the movement of the water. This process is called transportation. Large rocks can only be transported when the rivers flow very quickly, and that's because it takes large amounts of energy to move such incredibly large masses, and only fast-flowing water would be able to exert such forces. Flash floods are an example where large amounts of rock can be carried very quickly because the fast-flowing water is in such large volumes and has such a lot of energy that it is able to move rocks. And you can see here that the forces are sufficient that they've actually been able to move a whole car. Small rocks and rock particles can be transported by both fast and slow flowing rivers. Large rocks, however, may be deposited in areas where the river slows, and you can see this on the picture, that to the right hand side, as the water has gone round the bend and has slowed down, rocks and particles have been deposited on that far right hand bank. So now's your first opportunity to record some information that you've gained from the PowerPoint about transport. You should be able to describe what transport is and some differences between fast flowing water and slower flowing water. I'm going to give you the rest of this minute and a half to actually record that information about transport. Okay, we're going to move on. If you haven't quite got all the information down, feel free to pause the video to complete your notes, or you can make some additional notes at the end of the video. So we're going to move on through our stages of sedimentary rock formation to the next level, which is deposition. So eventually the rivers will flow so slowly that even the smallest particles will sink to the bottom. This is the process of deposition, and the sediments build up over time, covering previous layers of sediment, and it often occurs at the mouth of a river where it enters the lake or a sea, and will also occur within lakes and seas where sediments are dropped to the bottom of a lake or a sea. Again, I'm going to give you about a minute to record that information about deposition.
The Yorkshire Dales National Park covers 1,500 square kilometres. Different parts of the park have different surface rocks. Why is this? 350 million years ago, it was under a warm, clear tropical ocean. Skeletons of sea creatures collected in the bottom in layers. The sea became shallow and silty mud was laid down. Under its weight, the sediments were squeezed into limestone that cracked into vertical joints. Later, rivers washed sand into the sea. The mud hardened into shales, the sand into grit and sandstones. Then layers of younger rock built up on top. Earth movements cracked the whole crust along fault lines, and all this time erosion was shaping an undulating surface. Then in the last few million years, great ice sheets scraped away at the landscape. As they melted, they left sharpened peaks in some places and bare limestone in others. And the meltwater continued to run off over the fault line, cutting deep coves and gorges. Since the last ice age, humans have changed the landscape too. If people hadn't settled here, this would be ash forest.
So, sedimentary layers continue to develop and become thicker. The sediments which are at the bottom then get squashed because of all the pressure from the new sediments on the top of them. And this is called compaction. Compaction is what squeezes the air and the water out from between the layers, and the particles become closer and closer together. So deposition, the rocks and particles, the clasts, are dropped together and settle out, and then compaction, they're pushed further and further together, forcing out any water or air that's trapped between them, and that process is called compaction. So now's your opportunity to record what you've learned about compaction. And again, you have a minute to record that information. Right, cementation is the final stage to forming sedimentary rocks. Following on from compaction, where the particles have been squeezed closely together and water and air forced out, minerals glue the grains together to form the new rock. The type of rock formed depends on the combination of minerals and sediment grains that have been collected in a particular layer, as you saw in the video earlier on. So the sedimentation, the groundwater moves between the grains and leaves behind mineral deposits, and this is what cements or bonds the grains to each other. When all the space between the grains are filled, a sedimentary rock is formed. And they're seen as these classic cliffs where you can see all of the different layers with the different types of minerals that have been glued together. So, in summary, from weathering to sedimentary rock, the weathering and erosion process breaks down rocks from mountains and other areas. Land transport by the wind and water transport and ice transport cause the particles to be moved from one area to another, and deposition happens in the shallow waters where the sediments build up in layers. The layers are buried by further layers of sediment, and then that pressure from above causes compaction and cementation in order to turn it into sedimentary rock. So you should be able to complete the final part of our flow diagram about cementation. I'm going to give you again about a minute, but feel free to pause the video if you need more time. So what are these examples of? All four pictures show very different versions of what I'm sure you recognise as fossils. But what exactly are fossils? So a fossil is the preserved remains or traces of a dead organism. For example, when an animal dies, the soft parts usually decompose, leaving behind the harder parts, such as a skeleton or a shell. This will become buried in particles of rock called sediment as part of the sedimentary process. As more layers of sediment build up on top, the sediment around the skeleton becomes compact and starts to turn into rock, as we've discussed previously. The bones will then start to be dissolved by the water seeping through the rock, and minerals in the water can replace the bone, leaving a rock replica of the original bone called a fossil. And this is the reason why fossils are very, very common in sedimentary rock. And fossils are actually used in order to date rocks. Now, it's quite logical that as sediments form, the oldest sediments are at the bottom and the newest sediments, or the youngest ones, are at the top because of the process of them building up with the sediments being deposited and new sediments being layered on top. Therefore, it's also logical that the oldest fossils are at the bottom of any cliff, and the newer ones will be at the top in that younger rock. So if scientists can identify certain fossils in layers of rock, and then they can look at other rocks, they can use that to compare the dates of those rocks, because if they have similar fossils, it's logical that they are similar ages. So what are the typical characteristics of sedimentary rocks? Sandstone is one of those. As you can see, both of these examples are orangey coloured rocks, although sandstone does come in very many different shades. They tend to look like lots of grains of sand stuck together. They are often very soft, so they're easily crumbled and easily shaped. That's one of the reasons they were used for buildings for quite some time, because it was easy to carve them. And they frequently have clear layers. The example on the right is a good example of that. Limestone is another typical sedimentary rock. Again, this picture you can see the layers, although not as clear as in the sandstone. This one's a greyish white coloured rock. This one was made mainly from crushed seashells at the bottom of oceans and frequently contains fossilised shells, and again is soft enough that you can usually rub bits of it off. Chalk, another typical example. Again, grey or white coloured rock, again mainly made from crushed seashells, and again might contain fossilised shells. And this one is extremely crumbly. You know, chalk can be used for writing on things. Conglomerate looks a little bit different. It doesn't have the clear layers that are often present in other sedimentary rocks. However, it's made up of tiny particles, pebble size, so they have to be slightly bigger than 2 millimetres in diameter, but you can see that they're clearly cemented together. They look very similar to modern concrete in some ways. And then shale. Shale is very characteristic because it has extremely clear layers and it laminates or splits very easily across these layers. It's mainly made from compacted mud, will also contain fossils in frequent occasions, and there's often things like oil and coal deposits in as part of shale. So in summary, the characteristics of sedimentary rocks, they are usually soft and may even be quite crumbly. They often have clear layers, but not always. They don't contain separate crystals. They often do contain fossils, and they may contain coal or oil deposits. Some have empty air spaces in between them, which means they're porous. That means they can actually soak up water. And they often have clear grains held together by cement. So this is your opportunity to record any of the characteristics of sedimentary rocks. I'm going to give you a minute and a half to do that. So these are all pictures of areas containing sedimentary rock. Usually we see the rocks more clearly when weathering and erosion has occurred, exposing the layers to be clearly seen. On the right hand side there, you can see that sometimes those layers become distorted and moved as a result of movements of the Earth's crust, but we'll look at that in a later lesson. What you've had so far should allow you to answer the quiz that follows this on the Google Sheets. The second task on your Google Sheet is based on this slide. For those of you in our northern schools, you might actually recognise this cliff and know that it's Huntcliffe at Saltburn. But how could we tell that it's made from sedimentary rock? And how was that cliff formed over a period of time? You've got an opportunity to write an extended answer on your Google Sheet to tell us how that rock has formed over periods of time and what the clues are that tell us that that cliff is indeed made from sedimentary rock. So the following is a summary of sedimentary rocks and all that you need to know in order to answer the Google slides. So sedimentary rocks are made up of a mixture of bits of rock, sediments, and are formed by 4 processes. Transport, which is movement of those rock particles from where they've been formed to where they will be turned into a rock. Deposition, where they drop down by whatever medium has transported them. Compaction, where they're squeezed together and air and water forced out from in between them. And cementation, when they are literally glued together by minerals. Different sizes and types of grain and different types of cement will lead to different sedimentary rocks. And some of the examples you need to be aware of are chalk, sandstone, shale, conglomerate and limestone. And our characteristics of sedimentary rocks: they're usually quite often soft and might be crumbly. They often contain clear layers. They don't contain separate crystals. They often contain fossils and may contain coal or oil deposits. Some have air spaces, so they are porous, and they often have clear grains which are held together by cement. Now the final task is an optional task, and you may or may not have these materials to hand, but it's about making an example of a model of sedimentary rock. Because sedimentary rocks take thousands of years to form, we can use models as a way of explaining how they're actually made. To complete this task, you can use white, milk and/or dark chocolate. You need at least 2 different types, but it doesn't matter which combinations you use. You also can add any other bits of sweets or chocolate that you've got that have been crushed up very small. And you're going to need some cling film and a cup or another container to actually produce your rock in. So, chocolate sedimentary rocks. First of all, place the cling film into the cup or whatever other container you are making your rock in. You're then going to place 2 to 3 teaspoons of grated chocolate into the cup. I've suggested milk chocolate to start off with. You then need to place 2 to 3 teaspoons of a different type of grated chocolate into the cup. In this case, I've suggested white. And then next, 2 to 3 teaspoons of your third type of chocolate into the cup. If you haven't got a third type, don't worry, just keep going with the 2 types that you have. If you've got any extra bits and pieces crushed up very small, you're welcome to add them at this stage. And then you need to repeat a second layer with each type of chocolate that you have already used, and it doesn't matter what order you put them in. Then fold the cling film over the top of the chocolate so it's fully encased, and then push down hard until the chocolate feels like it's stuck together. At this point, you could borrow a parent who might have a little bit more force to do this with you. And then finally, peel off the cling film and break the rock in half, and you should be able to see your different layers. And the nice thing, of course, is that you're welcome to eat it afterwards. Right, I hope you've enjoyed this lesson. Will be another lesson on rocks to follow shortly. Thank you.